And Dr. Shantanu Kumar Bal has a long experience of more than 20 years in the field of agriculture methodology. He has worked in PAU Ludhiana and ICR system since last more than 20 years. He has obtained his graduation from the Orissa University of Agriculture and Technology, Bhubaneswar, and he completed his master's and PhD from the prestigious University of Punjab Agriculture University, Ludhiana. All of you might be knowing that PAU Ludhiana is second in ranking this year. So I congratulate Bal sir also for this. Presently, he is working as the principal scientist agrometallurgy in All India Coordinated Research Project on Agrometallurgy, CREDA, Hyderabad. And he is involved in several projects, out of which the two are the most important are the two externally funded projects by ICR NICRA and Monsoon Mission 2. As an visiting scientist to Israel under Mashal Fellowship, he has worked on database management in agriculture methodology and hydrology. And his contribution in the field of agrometallurgy was recognized by awarding him as a fellow of Association of Agrometallurgists and Indian Ecological Society. He is life member of more than 10 scientific societies and vice president of Association of Agrometallurgists, and also for the Indian Ecological Society, Ludhiana. He has worked in his career for more than 17 projects and published more than 50 peer-reviewed papers, 62 conference papers, 27 book chapters, and many more. He is also the editor, managing editor for Journal of Agrometallurgy and editor for the Journal of Agriculture Physics. And his team has a very significant contribution in developing various softwares, concepts, technologies, methodologies like post-hail management strategies for field and vegetable crops, prediction models for various insect and disease pest forewarning, dynamic crop weather calendar, etc. So many things he has developed, and we are fortunate that we have today with us Dr. Bal, and we will be enlightened by his talk. Welcome, sir, and thank you for accepting our invitation. Thank you very much, and welcome once again.
Thank you, Dr. Andale and organizers. So should I now share my screen?
Yes, sir, please.
Thank you. So thank you once again to the organizers, and welcome students and if any faculty members are there. So it's a privilege to always talk to students, because I was in Ludhiana and was a assistant professor teacher for around 12 years. So after that, once I moved to ICR, so this is the only way that I can interact with the students and other people, as there is no teaching now wherever I just work after leaving PAU. So when I was approached to give a lecture on a topic, agriculture, then I just immediately accepted the offer, and I just sent one title to the organizers that this may be the topic on which I would like to talk. But once the list I received from the organizers that who were the other speakers, so I could find that almost all are speaking on crop simulation models. So I was a little bit confused that whether I was wrong or maybe I could understand in different ways that what is the topic like that. Then I requested them to change my topic to this topic that I am just will be talking to you about, like understanding crop weather modeling, weather climate anomalies for climate smart agriculture.
Vaibhav,
Hello, sir.
I think there is some problem at the Bulser's end, I think, for the connectivity.
Yes, sir.
We'll wait for some time and we'll see. He'll sort out the problem over there.
Okay, sir.
Yeah.
Dr. Ravi,
Yes, sir.
any problem?
Yeah, I think there is problem in at the end of Dr. Bal sir. There is some internet connectivity problem over there.
Yeah.
We'll wait. He is sorting out that.
Okay, no problem. Go ahead. Will anybody from participant wants to speak? Anybody from participant, please raise the hand. Dr. Snehal, Dr. Snehal.
Hello.
Hello.
Yes, ma'am.
Sir, Bal sir join now.
Yeah.
Yeah. Okay. Go ahead.
Sir, please share your screen. Okay. It is visible, sir.
Okay. Dr. Barber, please welcome. Go ahead. No problem.
Hello, Bal sir. Please unmute yourself.
Okay, right.
Okay,
Now it's
sir.
fine?
Yes,
Okay,
sir.
thank you very
Yes.
much. So the topic assigned to me was crop weather modeling and weather climate anomalies for climate smart agriculture. So now I'll be a little bit fast because already 15 minutes has gone. So today we'll discuss about what is crop weather modeling, then what is crop weather climate anomalies, and how it can be used for climate smart agriculture. We all know that these are the few facts that how the India only 40% of the crop area is irrigated, 60% is rain fed. That means most of the area is rain fed agriculture. And if this temperature, CO2, and other availability as per the projection as well as what is happening, most years should the yield will be decreased. And in case of major food crop, the yield will be decreased as a whole. And most of the affected crop will be longer duration crops. And the expected loss will be more in Rabi crops compared to Kharif crops. And in most of the areas, especially in peninsular region, the length of growing period will be reduced. And if this climatic extreme numbers and extent increases, definitely the production increase or decrease, the variability will increase. And if this temperature increase and CO2 increase go side by side, the yield benefit that will be compensated. But if only we look at the CO2, then the yield will be increased by around 10 to 20%. And if you see as a whole, we can say that India will be mostly affected as most of the Indian population is dependent on the agriculture. So looking at that, let's first discuss about what is weather climatic anomalies. And as I understand that most of the now participants are students, so I would like to give some of the basic information to them so that it helps in understanding the concept so that they can use in their future research and other aspects. If you Google the word weather anomalies, these things actually come. So in any climate change studies or weather variability studies, the temperature anomaly is more important as absolute temperature, because in absolute temperature, if you know that a particular temperature condition of a particular place, then what we can crop. But if the temperature varies from that absolute temperature, or it goes plus or minus to that absolute temperature, then the problem comes, and that we call it as anomaly. And this anomaly is nothing but deviation from the baseline. And the baseline we got when you have a normal information, that means normal temperature, normal rainfall at a particular place. So when I will talking about weather anomaly and climatic anomaly, weather anomaly is basically is weather variability. Climate anomaly is basically about climate change. So basically, climate is what we exactly expect, what is going to be there, or what has already happened if you just analyze the historical data. And weather is nothing but what exactly is happening now. So when you compare the climate change with climate variability or weather variability, this type of shift, that means in daily basis or every year we have our climatic situation or weather as a normal, can say today's weather, the weather changes like that. But if there is any shift from this level to this level, we call it as a climatic change. And variability is the variation in between the years, that is known as your climatic variability. So these are the basic definitions that we all know, and how to do that I will discuss. And when you talk of any anomaly, whether it is weather or climate, then as a student, we should always understand that the statistics behind that, because the weather baseline, I just talked, what is the baseline, what is the deviation. So all those things, if you want to understand, we have a time series data. That means we should have a long-term data, maybe of 30 years, 40 years data. And when we analyze those data, then we can see what is the average value, whether there is a trend, the trend is increasing trend or decreasing trend, and what is the moving average, because the variability is so large, we cannot understand whether that the variability is going in which direction. So if we moving average, means we can average every 3 years, and that 3 years we can put in a trend, we can know whether that trend is a positive or a negative. And then another aspect is very important, what is the standard deviation. That means how what is the deviation from the baseline or normal, and how it is behaving. So all these terms, the statistical terms, that's why when I talk to any agrometeorology students, I just tell that agrometeorology students, if they are strong in statistical analysis and strong in a programming, definitely they have an edge over the. So, and when we'll talk of this time series type of functions like linear, polynomial, exponential, different type of functions are there, but we should try to understand that which type of relationship is fitting to which type of conditions and which type of parameters. That understanding also we should have. Then this is very simple for two images. You can see in case of temperature, if we put the temperature of from that 120 years data of IMD, we can see that the temperature previously, the variability from the normal, it was almost in the negative side, but in the last 20 years, we can see the temperature in the positive sides. And if you put a trend line, you can see the trend line starts from here. So in this 100 years, you can say that here a little bit around 0.1. So around 0.7 degree increase is there in the last 120 years. So this is just a simple statistical analysis to understand how the temperature has deviated from the baseline. Similarly, in case of rainfall, in case of temperature, you can see the variability is in the one side only. That means in some of the years it was in the lower side, in some of the years it is the higher side. But when you see at the precipitation, you can see the variability are almost in the other side. That's why the variability in case of precipitation is more concerned compared to the anomaly of the temperature, because you know that temperature is increasing every year. So we'll be prepared for that, or we can take some of the interventions, we can develop some of the varieties, we can withstand higher temperature like that, or we can change our place of planting, we can change our crop, we can change our locations, we can move forward to the northern side, or you can more. But in case of rainfall, if you see the variability is so large, it's very difficult to cope with this variability. And this is a very detailed analysis of the previous one. This precipitation, if you see in detail, you can see that this variation in different years. So that's why these years are the years where we will have droughts, and these are the years where we will have the floods. And this is the normal line or baseline. These are the standard deviation plus 10%, minus 20%, minus 10%, and moving average to see. And you can see the trend line. There are two trend lines. One trend line, if you see that from 1871 to 2016, it is around 150 years. The rainfall has decreased by 0.18 mm. Okay. And the standard deviation is very high. You can see it around 80 mm, and the mean rainfall is 852. This type of information, we have to be very clear how this average and this standard deviation and anomalies are actually there in terms of temperature and precipitation. This is one analysis of the around 120 data. Here, if you see, then while analyzing data, the basic purpose of showing this information is that you can see here only simply I have put a linear regression type of equation, and if I have divided the whole series data around 120 years data into 4 groups. So first group, you can see the first 25 years there is one trend. This is the average baseline average. The second, there is another average. Third, another average. Fourth, another. So that means the temperature average is increasing in the last, and if you divide into 30 years, 30 into 4 is 120 years, you can see the average how. So temperature has increased, and this temperature increase we can reflect in a linear also, but the function here is not a linear from here to here. We can segregate the whole information into small linears, but if you take from here to here, the information will be erroneous. So same data, when I have put in a second order polynomial, you can see the polynomial is like this. And you can also see that here R-square value is improved from 0.50 to 0.70. So this equation fits more well compared to that of this equation. That means this is more accurate. Means in the initial years, the temperature has decreased little bit. After that, it got stabilized. Then it is increasing. Then so this type of function is mainly known as second order polynomial. And if you put the third order polynomial, R-square is still more. Fourth order, it is still more 0.83. But sometimes what happens, if you increase this order of polynomial, the complexity of the equation increases. So we will unable to explain the complexities. So in that view, we should compromise. In some of the cases, we have to compromise in whether to go for second polynomial or fourth polynomial. But the question is that complexity will increase, so our interpretation will also be difficult. So that transition, we have to decide whether we should stop at second order polynomial or at fourth order polynomial. And these are the simple example what I am just tell that this is an example of the long-term time series analysis. And also we should know that anomalies in terms of like dry spells. For example, in a particular place, the average anomalies, the average baseline says that there will be a 7-day dry spell. So we should also see whether this 7-day dry spell is increasing or decreasing in a particular place. So that anomaly we should quantify. Similarly, 14 days. That means if the anomaly is more, to be very careful while any crop in that particular place. Similarly, the length, if you want to place, the length of growing could be such that can be grown. Suppose and these are mostly applicable for the rain-fed conditions where we only depend on the rainfall. So if your growing period does not match, your growing period is decreasing, so we have
Snell, I think again Dr. Bal is disconnected.
Yes, sir.
Why?
We have
Why?
some network problem over there.
Hyderabad is I think he's joining from not from office anywhere, because in office very good range is there.
We'll wait for him.
Okay, no problem.
Bal sir, please unmute yourself.
Is it visible?
Yes, sir.
Okay, now it is fine.
Okay,
Okay,
okay.
thank you. So I think it was the last slide.
Yes, sir.
Yeah. Okay. So when we talk of then, when you understand this climate anomalies, then climate change is nothing but how we understand this higher and minimum maximum temperature and the increase in untimely rainfall, delay or beginning of monsoon, and less stable monsoon rain. So all these things we all know that how this climate change is affecting all these things, and this ultimately are affecting our crop productivity. So once we understand this with climate and weather anomalies, then also we should understand what is our perception, because the perception changes from person to person. As a researcher, you may take one thing in certain way, but I may take that particular aspect in other way. So for example, if you talk of crop weather modeling, some people think that crop weather modeling means it is only crop simulation models like this and I've seen all that. But no, crop weather modeling may be a simple model that I'll just tell you after that. And similarly, the perception about climate change, weather anomaly, climate anomaly also changes from person to person. And another thing also is to understand that even if you understand the weather and climate anomalies, but every crop has its own sensitivity to the anomalies. For example, if temperature decreases by 2 degrees, the maize will respond to it differently, soybean will respond to it differently, and wheat will also respond to it differently. So the weather anomaly and climate anomaly should also be assessed to look from the sensitivity point of a particular crop. So I will not go into much detail because this connectivity issue is there. So when you talk about crop weather modeling, question is why there is a need to model the crop weather relationship, because we know that crops respond differently to different weather conditions, climate conditions. And to quantify what is the relationship, we should go for the crop weather relationship studies, or which we otherwise call it as crop weather modeling. Once we model it in future, we can use those models to understand the impact of any climate or weather variable on the particular crop. And why this weather and climatic information is useful in agriculture, we know that in various agricultural operations are affected by this weather and climate. And to look at that, this is a very good simple here you just see that how this deviation of rainfall is impacting the crop yield, because if you understand this, and you can model the crop weather relationship. In pre-sowing, if you see, this is the duration, and if this is the amount of water requirement, how much exactly is received by the crop, and ultimately how it is affecting the productivity. The simple example. And similarly, we can also see that what is the relationship of this radiation used in a particular crop. These are all the work of the AICRP and agrometeorology centers that we are working. The rice, you can see when the accumulated intercepted power is increasing, it is there in case of rice. Similarly, in case of potato. The same way you can see how this total dry matter is affected by the growing degree. That means heat unit. Heat unit is nothing but it is the average of the maximum temperature. So if the temperature of a day, if it is that quantified temperature, if we accumulate, how it is actually reflecting the, we can call it as crop weather models. This is with respect to growing degree day. So this growing degree day is nothing but weather, and this is yield. So this information we can call it as a crop weather model. For example, this is clear-cut example of a crop simulation model study output. Here we have tried to model the impact of a single day irrigation on a soybean. This is a work done by our center of Akola. What they have done is how a single day irrigation can save the soybean crop. That has been modeled by the DSAT these are a crop simulation model. And this is also we can call it as a crop weather model. It's a thumb rule model. That means from the years in which we get higher yields, in those years, what is the maximum temperature range, minimum temperature range? If you can compile, we can say that this is the best weather which leads to better productivity or better yield. So those information we can convert into a crop weather model. So thumb rule is also a crop weather model. Similarly, Equipam has developed its own sort of algorithm-based model, which we call a dynamic crop weather calendars or models, by using this growing degree day concept and water balance concept. And so this information we have just compiled, and now we have made a program so that we can model the effect of different weather variables or factors on the yield of the different type of crops. So this is about, it talks about crop weather model. Everybody thinks that it is crop simulation model, and these are also different type of models which can simulate the impact of weather on the crop yield or productivity. So when I talk of crop weather models, so even a single regression based y is equal to a plus bx is a crop weather model. The model that we have developed, DCWC, is a crop weather model, and this DSAT, AppSim, InfoCrop, first like crop simulation models, also we can call it as a crop weather models, because all these crop weather models are used to understand the soil plant weather and crop management interactions. So when we talk of any crop weather model, we know that there is input and there is an output. In case of input, we need, just like in your simulation model, we have weather data files, soil data files, crop data files. Similarly, in other models, like parametric regression models or DCWC, like models that you have developed, or crop simulation models, that input, when you put this weather data, soil and crop data, in output we get the phenology, yield, and water use. Okay, for example, and weather file, as in case of crop simulation models, we have weather files. In the weather file, we put the historical weather for 30 years, 40 years, like that. Similarly, in case of other crop models also, more number of year data is available. It is always better to model any relationship. And this weather file are two types. One is realistic, second is probabilistic. For example, simulation model, we use a realistic and historical data, and probabilistic is that any climatic scenario proposed by IPCC or some other year. So that type of information also we can use in other crop weather models. And this both information may be used in terms of weather variability, in terms of climate change. And what are the basic understanding that we need to use this? Because one thing I told that in case of any model, when you try to build, the long-term weather information is required, and the years, there is not any definite period that it should be 10 years like that. But as more number of years to be data is available, the reliability of the model increases, because your understanding, your confidence level also increases for that particular model. And secondly, once the data is available with you, what is your data analytical capabilities? Because previously we are using the Excel for analyzing any data, but nowadays we can see many programs have come and people are becoming more and more this programming savvy. So once anybody have expertise in those programming and these statistical programs, so your data analytical capability improves, and it helps in you to understand the whole data series in a better way. And also you should have understanding of the climatic scenarios and RCPs of the IPC, so that you can also use what exactly will happen the next 20, 30 or 40, 50 years. And besides that, once if you want to develop a crop weather model, you should have a better understanding of the plant processes. like photosynthesis, transpiration, soil water dynamics, crop phenology, and also the soil plant atmospheric continuum. How actually the different metabolic activities are happening inside the plant. If you understand how temperature affects photosynthesis, how water availability to water use affects photosynthesis, what is the soil water dynamics, when we apply irrigation, how it behaves. So if you understand all these things, so ultimately it will help in building a good good model which you can understand, also you can put into use. And second aspect, once you develop any model, the second aspect is to validate. Validate means, because you have understood the anomalies, then you have understood the crop behavior, then you have tried to build a model which predicts the yield. Suppose, for example, yield or water use or phenology based on the different weather variables. But whether that particular model is working or not, how to see that or how to test that, for that we need validation of our models. For example, in case of one of our work, we try to validate the sowing date predicted by our model, and you can see the agreement between the observed sowing date and the predicted sowing date are almost around that 1-to-1 line, and R square is 0.93. So now we can tell that our model is actually predicting the sowing date very well. Similarly, we have tried the crop phenology for different crops at different locations, because sometimes what happens, once you develop a model for a particular place and you try to use that model in another place, that model does not work. So while using a model in other place than where it actually been developed, so you need to calibrate and validate. Same thing we do for the crop simulation models. And once you understand this weather climatic anomalies and crop weather modeling, basics of crop weather modeling, because one day you cannot be expert in crop weather modeling, but if you understand the basics of crop weather modeling and the weather climatic anomalies, then question is how to integrate these two so that we can use these in the agricultural operations, so that our agriculture can be climate smart. And we all know that whatever effort we do, we cannot make our agriculture 100% climate smart. The question is, what is climate smart? At least we can understand the climate to some extent, and we can take some of the interventions so that the loss due to climatic and weather anomalies can be minimized. Our job is to minimize the risk involved in the agriculture by understanding the anomalies and by developing good crop weather models. And if we use these two, we can help the farmers or the farming community to take some of the decisions which can help in improving their yield and also the risk involved in their farming processes. So then question is, what is our perception and understanding? Because nobody has clearly understood what is climate change and what will happen, when it will happen, how much it will happen. And if you look at the climate change, and it's we know that the effect is so slow that but nowadays a lot of scientists are doing work has been done. But question is that if temperature increases by 1 degree, this impact will be whatever impact will be, but at that time maybe we could have developed many varieties, something like that. This is one of the theory, or one of the people. Some of the people think in that way. Some people think that the threshold effect will be so high that and that critical value, so its impact will be very high. And third concept is that even if climate changes gradually, but our past experience will not work much, because the impact will be beyond our understanding. So while looking at these climatic change impact studies understandings, these type of uncertainties has also been taken into account. So as a researcher, as a student, you should understand that whenever anybody talking about climate change, climatic anomalies, weather variability, we should always look into all the three aspects, that how these anomalies will impact the agriculture, maybe in the next 5 years, 10 years, 20 years, 30 years. So the time frame is also very important to look into. And then these are some of the basic information. Just now I'll try to skip because due to this connectivity issue. So because the program is being conducted at MPKV and is Maharashtra, so I just took this slide. There was a survey, and the Maharashtra farmers, they observed that there is increase in temperature and prolonged summer months. Summer month has prolonged, and some of the farmers perceive that climate change in terms of changes in rainfall, which as per them is actually decreasing. So the purpose of telling all this, that because again this perception, because in 2-3 slides I have emphasized the word perception. Your understanding about anomalies, your understanding about crop weather model, all depends on how you perceive the things. Means what is your perception about all these things, climate change. So then we all know that how this agriculture is being affected by various weather elements. These are very elementary things we all have studied in our courses. The question is that these anomalies are reflected in terms of maybe rainfall is decreased in the there is a break monsoon, there is no rainfall, so it will lead to mid-season drought. If monsoon comes late, so these are all anomalies. So because by showing up this slide is that these anomalies lead to these drought conditions if there is a change or anomaly in the monsoon. Similarly, cardinal temperature, it is linked to the air temperature. If there is anomaly in the cardinal temperature, so the type of crop we are growing, it may be affected. So, and also that country has been divided into different agroecological climatic situations based on the basic weather variables and weather informations. So if there is any change in those variables, then definitely that the crop that we have selected for any particular region, it will be impacted. So this revision of this agroecological regions is also need of the hour, because for the last because this was developed 30-40 years back, and the climatic situation has been changed in the last 34 years. So this type of because this is a baseline. Why I'm showing this, that when you talk of baseline, because this is the average conditions which we have depicted in a map, which we call it as agroecological region or sub-region. But this baseline has been changed during the last 34 years. So when the baseline has changed, we cannot understand the anomaly in a better way. So these maps need to be revised. This is the need of the hour. And also, we know that for different agroecological zones, we have different soil factors and soil moisture status. On that basis, we can select our crops. And also, these agroecosystems, based on the agroecosystems, we have divided the country into different production systems, like arid agroecosystem, coastal, hill, mountain, irrigated, rainfall. And based on these agroecosystems, the production system is identified. So what I want to convey is that because there is a change in agroecological conditions, so this has also impacted these production systems. And these production systems, in each production system in agroecological regions, we have different farming situations. And farming situations like that, for example, in arid, our farming production system is like your pearl millet, oilseed based, pearl millet based. In coastal, we can have, so this type of production system have been developed based on the agroecological conditions, and that is nothing but the baseline. So when there is a change in that baseline, and also the change in climate, change in weather variability, so this type of production system needs to be re-evaluated. And then question is finally, how we make agriculture climate smart. We all know that once we understand these anomalies, and we understand and we have developed, we know how to develop these crop weather models. Then we, because in that case, our understanding about this variability, whether it is terms of weather, climate change, and also how these variabilities can reduce the risk, and adapting proper mitigation strategies, adopting proper adaptation strategies, developing climatic analysis. What is climatic analysis? That if you understand that in a particular climate, particular variety or particular crop is growing in a very better way, so we can find out similar places in the country where the same type of climate is available, so that we can promote those type of agriculture which are already growing in a particular. So this type of information we can develop by using our crop weather models. And also by using the crop weather models, we can improve the use efficiency of natural resources. When we talk of natural resources, it may be air, it may be water, it may be light also, because light is free. We don't consider it as a valuable things, but we have to use those resources, and those that we can, because one slide has show you how this radiation can actually can be improved by using these models. So this type of information has productivity and the crop yield. And once you do that, and when you talk of how this crop weather models can be used, or applications of these crop weather models, for example, I want to give you some of the current applications that is being done. In case of weather-based crop insurance triggers, by using these crop growth models, we have developed these triggers, which are being used to give the insurance to the farmers, a compensation to the farmers. Then, for example, in crop cutting experiments by the Minister of Agriculture, these technologies are crop weather-based model technologies are now being planned to replace the crop cutting experiments, because by using technology, maybe crop weather-based models, we can know what is the extent of damage that is going to happen to the crop. We need not conduct the crop cutting experiments. And shift in agronomic management practices. We all are using different crop simulation models to know if we shift the sowing date, how it will affect the crop yield. So those type of simulations, those type of options we can get by using these crop weather models. Yield gap analysis. We know that a particular place yield is not up to the mark, because it is not up to the mark because of some constraint in terms of weather and climate. So if you build a robust crop weather models, you can understand that what is the gap, and we'll try to just make up that gap. And preparing climatic analogs that I have already told, we can identify similar places where the same crop can be grown. And also we can also decide what is the best on-field practices which you can use, so that the natural resource use efficiency improves. We can save water, we can save maybe seed, because if we can give a timely sowing advisories, we can also save the seed. So these are some of the applications of these crop weather models based on this crop and based on this weather and climatic anomalies. And finally, what I can say that as a student researchers, and we are also, because we are also into this research line, many questions come to your mind, and these questions need some answers. But there is not any absolute model. We know that model, everybody call it as a garbage in and garbage out. That means anything we can put in the input file, as input file, we get some output. But question is how you understand that output, what is the output, whether it is applicable to you or not. And this and when you use any model, you get a lot of outputs. So output is nothing but decisions. So out of those decisions, which decision you should accept, which you should reject, that depends on your understanding about the model, about your climate and weather, that baseline anomalies, all those things, and also about your perception, how you perceive the things. What is your knowledge about crops, knowledge about the cropping systems, knowledge about how a crop behaves to different kind of extremes. So, and this decision making is not going to be simple in the future. It will be more complex and complex, because climate and weather is becoming more more dynamic, and its extremes are increasing, and this climate weather anomalies will increase, and which will make the life of the farmers difficult, that we all know. But question is that how we can deal with. But as researchers, our role is to do the best that is available. And if you understand the anomalies, this is my final statement, and also able to develop robust crop weather models that are already told, we will have many answers for decision making. But the question is that how we will take those decision making answers, and how we can use that in the fields. That depends on our success, and that depends on how best we can be good modeler, or maybe researcher, so like that. So in the whole, this is because when the organist approached me, the topic I just first gave to them, that does not include this crop weather models. Basically, it was on weather climatic anomalies. But once I saw the list of other speakers, I saw that almost all speakers are talking about the crop simulation models. So then the thing came to my mind is that, is the crop weather models is about crop simulation models? No. Crop simulation model is only one type of crop weather model. So then I thought of speaking something about crop weather models, so that the understanding of the young researchers will be clear about, because these are basic questions that anybody faces in the interviews or somewhere you go. So I think with this, I will stop my presentation, and now let it be open for any discussion. Thank you very much.
Thank you, Dr. Bal. Nice lecture.
And also, I'm sorry for the interruptions, because there was some issue with our institute internet.
No
connection.
problem. No problem, sir. It happens.
No issue.
It's okay. Sir, can we take up some questions from the
Yes,
participants?
Yes, I'm there. Okay. So kindly just, I'll be happy to just because it's a good opportunity to talk with the students.
Yeah, just for your information, we have students from all over the country, and also the researchers and faculties from various universities over the country. So nearly 50% participation
Okay.
is from students and faculties.
No problem. I'll be there to answer.
Yes, sir. Yes, sir. I'll request the participants to post their questions in the chat box, and our coordinators will take up the questions one by one, so that our expert can answer the questions placed by the participants.
Okay, sir. First question is from Daesh, Mr. Daesh. Can we use such models to predict effect of climate change on economically useful algae or seaweeds?
Okay, it is very simple, because in my lecture you could have understood that model is nothing but any relationship in which you can predict any effect. The effect may be in terms of yield, maybe in terms of water use, maybe in terms of anything, and how the weather and climate affects that particular entity or subject. So if you want to do modeling on this seaweed or something like that, then question is that you should have information about that seaweed, its growth, its other aspects, and also information about climate in that particular place. And when you are talking about sea, then definitely sea temperature, then other factors of sea maybe that will be there, yeah, and that information if you have, then you can definitely develop some of the relationship, and those relationship definitely it will work. and the models are different types. So it's up to you. It's up to your strength and your capability to understand and to develop that model.
Thank you, sir. Next question is from Advija Datta. How we can know where to use crop simulation model or statistical model?
Okay. That's a very good question. The question is that you should understand what is a crop simulation model. Crop simulation model has been built based on the regression models, because for long-term experiments we have done on that experimental output or results, we have developed different kind of regression models, and those regression models have been compiled to make a big crop simulation model. And for a crop simulation model, you should have detailed information. Otherwise, your output of the crop simulation model will not work. And in case of normal regression model means when you want to see effect of only one parameter or 2 or 3 parameters on a particular that is when you're dependent variable, independent variable. So it all depends on what exactly you want to do using this crop simulation or crop weather-based models. So basically, for example, if I want to see the effect of temperature on the crop yield, and I have information about for a long-term data like 10 years data, I have field experimental, then I can develop a very simple parametric linear regression model, which can in which the model can predict the yield based on the deviation or the changes in the temperature. So it all depends on how what exactly you want to see. And in case of crop simulation models, what I have already told, it needs a detailed information about your subject so that you can run that model.
Thank you, sir. Next question is from Dr. Umed Singh. Are the models specific to crop and climatic conditions?
There are some models which are very crop specific, but nowadays many models like DSAT, AppStream are there where you can run different type of crops. There are designated crops are there, so you can select that crop and accordingly you can put your input files, and it will predict and you will give different type of outputs. But that you can validate whether it is working, because most of the models have been developed in the outside. Besides that, Infocrop is of Indian. So that is one thing. And what was the second question of Dr. Umed?
Snell,
Sir.
Actually, Dr. Umed had two questions. One question was whether these crop simulation models are crop specific or not. He had also asked another question. In that same question, there are two aspects.
Snell, can you repeat the question by Dr. Umed Singh?
Yes, sir. First question is, are the models specific to crop and climatic conditions?
Okay. Regarding the climatic conditions, the crop simulation models have been developed. Suppose the DSAT was developed using the experiments done at Western countries, but later they have also included many experimental data of India. Once Indian scientists started using that, and definitely the crop models they behave in a certain way, because what type of input files are there already inbuilt in that. And if you take very different kind of climatic situation where you grow your crop, definitely the model output will be different. But you have to do proper calibration so that you can use that in your particular climatic conditions.
Thank you, sir. Next question is from Dr. Raghavendra. Can we predict weather parameters by using DSAT model? If yes, Please explain how we could do that in DSAT model.
Actually, very model specific questions I cannot answer because nowadays I'm not running actually the crop models. But I do know that there are models where that climatic generators are there inbuilt, like in crop cyst model. There is a ClimeGen module which can generate climate for the future situations, and also can generate climate based on the whatever 30 years or 40 years data you have. That it will check the data, and it will do some machine learning, and then it will make an output. That output is nothing but a generated climatic conditions. So it is available with the models, and there are many modules like ClimeGen are there. So you can definitely use those for generating climatic conditions, and then also you can compare. For example, I have a data set of 1970 to 2020. I can use those 50 years data set using the ClimeGen software or any climatic generator software. I can generate the data of the same years of 1970 to 2020. Then I can compare what is the actual data of 50 years available with me and what is generated by the climatic generator. And then I can compare what is the actual climatic weather data of my station and what is the generator has predicted. So I can compare and say that what is the compatibility of these two data set. Because I had one paper in Journal of Hygrometeorology maybe some 20 years back. I used the ClimeGen software. So that can be done. You can use.
Thank you, sir. Next question is from Dr. P. Sitaramu. How best we can simulate the weather data with the incidence of pests and diseases?
No, you need not simulate weather data. What you can do, you can understand the weather data set that you have, and in that particular weather data set, how these pests and diseases are behaving. That means if I want to establish relationship between suppose for example the bacterial blight of in pomegranate is a very severe problem. So what we have done we had a collaboration with the National Research Center for Pomegranate. So they have given us 12 years data of that bacterial blight on pomegranate and the weather data. So we have analyzed and we have developed some decision-based models where we can predict the bacterial blight in pomegranate. So this can be developed. Only thing is that you should understand the dynamics of weather and dynamics of the pest or disease, and you try to bring both into one platform where the disease can be predicted by using the different weather variables.
Thank you, sir. Next question is from Vibhuti Gupta. What is practical applicability of crop models in the field by the farmers, as they are not much aware about these technologies?
Yes. We have several models available in this country, and many scientists are working on the crop models. And this crop model has tremendous potential because that's why in my whole lecture I just wanted to tell that how you take these models and what is your understanding, and these models can be used by the researchers, not by the farmers. So that is the reason why the simple models, model, if it is simpler, then it is easy to use. But the farmers need not use the models. But now you know that this district agromet units have been set up, and subject matter specialists have many DAMUs they have joined. So what the plan is that these subject matter specialists, you will be given one sort of module or maybe some software like that. So they will use the software or the crop model. They will then have some output, and they will use those information in the crop agromet advisories. so that farmers will be benefited. So farmers are not there to use the models, but model or any crop weather model will be used by the researchers. Output will be used by the farmers.
Thank you, sir. Umid Singh, sir, please unmute yourself and ask your question.
Hello, Dr. Saab, good evening.
Good evening, Dr. Saab.
How are you?
Fine, fine.
Actually, we are not well versed about the models, though we want to work. Say that's why I was asking that there are the crops. These are particularly adapted to the arid region, wherein drought is also a problem and rainfall is also very low, and the most of the crops are like seed spices, cumin and isabgol, and other cereals are like pearl millet. So I was asking that is there means a specific model applicable to the arid region and for this type of crops, or the simply the other models that applicable to other crops are also useful for us also. So in
Dr.
this
Saab,
line, please
the
guide.
question is that in case of spice crops,
Yes.
you won't get many models. First of all, second is
Okay.
try to develop the parametric based models like regression based models. Try to develop first, and there are
Okay.
many, even nowadays also in case of spices, not much models are there.
Yeah.
Because we all are working for the major crops like rice, wheat, maize, and pearl millet, sorghum, all those things. So
Yes.
it is the need of the hour. And if you really want to work on this, we'll help you. No problem. We'll help you. But question is that if you have a long-term data set, for example, cumin. In case of cumin, if you have experimental data, long-term data, those data can be analyzed and we can develop some of the basic models.
Okay.
So that we can talk maybe personally. You can talk to me. Thank you.
Yes, we can talk up on the cumin and pearl millet two crop.
Any you just talk to me personally. We can discuss.
Okay. Thank you.
Thank you,
Dr.
thank you,
Thank you very much. Yes.
Thank you, sir. I'm going to take last question from Ved Prakash. Can we simulate the solar radiations under agroforestry system in shade as well as in open sun condition by using crop models?
That's our question is that there are some, if in some model you have both the components like crop as well as agroforestry, maybe some trees. If that is available and you can run as a solo crop or as a combination of crop in that model, and then definitely, and you have also the field observations like in a single crop. For example, in the agroforestry you have poplar plus wheat. In poplar plus wheat, suppose you know the radiation distribution, how the distribution is there if there is only poplar crop is there, how distribution is there if there is a poplar and wheat combination, and if you have both the conditions and then you run that in a particular model where both the crops are available, definitely you can simulate the but because we know that simulation is nothing but representation of the actual. So if we have long-term actual information, those information we can use and we can simulate. So that will be my answer. And if Dr. Ved Prakash, if you want, you can also talk to me personally, no problem. I think
Okay. Thank you, sir. Hello.
बोला. Hello.
Snehal, carry on.
Sir, questions are over, sir.
Questions from chat box are over.
Yes, sir.
Okay, if anybody wants to contact Dr. Bal personally, sir, shall we share your email ID with the participants
Yes, you can say.
so that they can personally contact you for
Definitely.
future
Even you
queries?
can share my mobile number also.
Okay. Thank you very much, sir.
There is
Thank
no
you.
problem.
Thank you.
Anybody can contact me.
Thank you very much. We'll share the contact number and email ID
Yes,
with the
yes,
participants,
yes.
and they can personally contact you for further queries also.
Yeah.
Snehal, so shall we wind up today's session?
Yes, sir.
Yeah. So now I would like to thank Dr. Bal for accepting our invitation and presenting his very informative and elaborative talk on the topic understanding crop modeling. It was just not understanding crop modeling, but how to make use of the crop models into the mitigation strategies, adaptation strategies, and making the agriculture more climate smart. He has made us understand it very well, and I think the participants are benefited by this talk. I would also thank Dr. J.D. Jadhav, head of the department, Agriculture Methodology, Kasam, Pune. And the most important thing, our coordinators, Dr. Vaibhav Malunchkar and Dr. Snehal, they are taking a lot of pains during this organization of the training. I would also thank them. And most importantly, participants. They have shown very keen interest and asked very important questions placed before the experts and satisfied themselves. I think if in future also they can contact the expert, any of the expert which we have called for this training. Thank you very much. Thank you all participants. And once again, Bal sir, thank you very much.
Thank you, Dr. Ravi. Dr. Bal sir, thank you very much.